This is the video for the Introduction to Rational Expressions and the beginning of Chapter 7, Section 7.1. And we're going to start off with the definition of what a rational expression is. A rational expression is a ratio, or fraction, of the form p of x over q of x, where p of x is called the numerator and q of x is called the denominator, just like in a regular fraction. But in this instance, p and q are polynomials, and q of x is not the zero polynomial because we do not want to be dividing by 0. So, what do we want to say about this? Well, this is just a fraction made of polynomials. So some quick examples might be x plus 2 over 2x plus 3. Or 1 over x is maybe the simplest one you could have there. And it could be pretty complicated. X cubed minus 3x squared plus 1, all divided by x squared plus 2x, right? They can be complicated, they can be simple, but what they all have in common is they are fractions made up of polynomials. Also, we're quite interested in making sure that the denominator is not 0. So in each one of these cases, as we'll see later, we want to ensure that the denominator in each one of these cases does not equal 0. And so, that's going to involve maybe sometimes factoring or setting something equal to 0, but basically to ensure that the denominator q of x is not 0, we will have to solve a polynomial equation. Typically by factoring, which is what we were doing at the end of chapter 6.5, that polynomial review that we went over. A couple more things before we go on. There are some striking similarities between rational expressions and fractions in general. Most common of which that you need to be familiar with is what's the difference between a fraction that's 0, a fraction that's not 0, and a fraction that's undefined. So let's go over those really quick. 4/3 is a defined fraction. It's a little bit weird to talk about a defined fraction until you talk about an undefined fraction. We'll get there. 0 over 5 is 0. So specifically here, when the numerator is 0, the entire fraction is worth 0. And then finally, if you have something like 4 over 0, this is undefined when 0 is in, or I shouldn't say 0 is in the denominator, because a lot of people make the mistake of thinking that our variable can't be 0. So when the denominator q of x equals 0. So quite often in a lot of these situations we may take the numerator or the denominator and set it equal to 0 to distinguish these different situations. If they're both non-zero in situation 1, you have a good old-fashioned defined fraction. When the numerator is 0, it's still defined. That's okay. It just happens to be defined as 0. And then in the third situation, whenever the denominator is 0, and that actually includes things like 0 divided by 0 as well. So the denominator is still 0 there, so it's not equal to 0. This is undefined. Undef, as we say. Anyway, that's a quick little introduction to some ideas about fractions that you should know, as well as the definition of what a rational expression is. So let's take a look at a pretty basic example. We're going to evaluate the rational expression 2x minus 6 over x squared plus x minus 2 for the following values, x equals 0, 1, 2, and 3. So we're just going to run through some numbers here. All they're asking us to do is plug these values in for x and simplify and interpret what we see. So let's see here. For part A, you guys like to part A? If x equal to 0 here, then we have 2 times 0 minus 6 divided by the quantity 0 squared plus 0 minus 2, which is equal to 0 minus 6 over 0 plus 0 minus 2, which is negative 6 over negative 2, which is 3. Now the reason I chose 0 as my first input was to show you that just because x is equal to 0 doesn't mean necessarily that the value of the fraction is 0 or that it's undefined. So let's really sort of annotate that. Note, just because x equals 0, this does not mean the rational expression is 0 or undefined. You're not going to be able to determine either one of those until you actually plug the value in and simplify. This has to be actually defined. So we typically don't write that, or as a student you wouldn't write at the end of your answer, hey, this is defined. But if we get in the habit now, it'll be a little bit clearer when we get to something that's undefined. So I'm just setting a precedent here. Okay. So when you plug in 0, you get out 3. But what if, man? What if x is equal to 1? Well, if x is equal to 1, then we have 2 times 1 minus 6 divided by 1 squared plus 1 minus 2. And that's equal to 2 minus 6 over 1 plus 1 minus 2, which is negative 4 over 0. So this is undefined. We have a 0 output in the denominator. Okay, well, maybe that's straightforward. Hopefully you'll take that at face value and not look too deeply into that. If the denominator is 0, it's undefined, and that's all we were looking to illustrate here. C. X is equal to 2. If x equals 2, we have 2 times 2 minus 6 divided by 2 squared plus 2 minus 2. Remember, all I'm doing is plugging stuff, substituting those values into this expression for x. Simplifying this, this is 4 minus 6 over 4 plus 2 minus 2, which is negative 2 over 4, which is negative 1/2. And that is a defined value. Defined. Nailed it. And one more here. Let's see. D, if x is equal to 3, we're going to get 2 times 3 minus 6 divided by 3 squared plus 3 minus 2, which is 6 minus 6 divided by 9 plus 3 minus 2, which is 0 over 10. And that's actually equal to 0. It's still defined. 0 is a real number. But here, the numerator equals 0. So the entire expression equals 0. And there you have it. That's a simple introduction to rational expressions. So we have our definition and we know how to plug in values. And more specifically, we have looked at the difference between when something's defined, when something's specifically defined to be 0, and when something is undefined.